All right, it's keeping on. Here's number 8. I have two terms going to 1, so eventually I'm going to have to blend these two terms together. And if it was anything like, hold on just one second, let me scroll up for it. Hopefully I don't give you guys a headache doing this. But look right here, I went from 2 terms to 1 term, and the way I did example 5 was I got a common denominator. Okay, so if I went from several terms down to 1, I had to get a common denominator. And if we look here at example 8, I'm like, I don't see denominators. How am I going to get a common denominator? Well, we can create denominators, because I know that cosecant is 1 over sine of t. Cotangent is cosine t over sine t. And I'm going to multiply it by, let's go ahead and write cosine in a fraction. We'll write it as cosine over 1. Okay, so really what I have is 1 over sine of t minus, combining these together in one fraction here, cosine squared t over sine t. I already have a common denominator. That really helps. So let me just go across the top is 1 minus cosine squared t over sine t. And don't we have an identity for that one right there? Our identity that we're very familiar with is the one that says cosine squared t plus sine squared t equals 1. So if I just move the cosine squared over, it's telling me that sine squared t is 1 minus cosine squared t. So I get to replace all of 1 minus cosine squared t with just sine squared t. There we go. So sine squared t over the denominator that we have. You've got 2 in the top with 1 in the denominator. All that goes away, and my answer is just sine of t. Okay, so again, it's just realizing this problem that the only way I can blend several terms together is to create fractions, so that way I can add fractions and get common denominators. Okay, example 9. I have sine to the 4th, cosine to the 4th, and on the right I've got sine squareds and cosine squareds. Well, I only have identities for squareds, so my first thought is to write it as sine squared x times sine squared x plus cosine squared x times cosine squared x. Okay? So now the next step is realizing, okay, I've got them down to sine squareds, I've got them to cosine squareds, so I have some identities I could use. Or not really identities, just one identity, that identity that cosine squared plus sine squared equals 1. So how do I go? Do I replace both of them? Or all 4? How does that work? Okay, so this is me kind of being Miss Teacher and helping you guys out through this. If you have the option to make replacements, like here I can replace both the sine squared x, both of these here, and both of these cosine squared x's. This is me helping you guys out. Only choose to do one at a time. Okay, so I'm saying I'm going to leave this first one here, but instead of this sine squared x, I'm going to replace it. And what I know is that sine squared x is equal to, move that over, 1 minus cosine squared x. Okay, and then again in this pairing, I'm only going to choose to replace one of them, where cosine squared x is, now this time I move my sine over, 1 minus sine squared x. Okay, try that first. If it works out, then you're good. If it doesn't work out, the next thing I would do is come right back to this step and replace actually all four terms, or both terms in each pairing. Okay, but for right now I'm going to try just one at a time, and then I'll see how it works. So sine squared, I'm going to distribute it, is sine squared x minus sine squared x cosine squared x. Over here on the right, cosine squared x times 1 is cosine squared x minus sine squared x cosine squared x. Okay, well I've got some like terms. The sine squared x and the cosine squared x happens twice. There's 2 negatives. So I have, okay, sine squared x, I have a cosine squared x, and I've got 2 of these, a negative 2 of them, of sine squared x cosine squared x. Okay, so that's good. That's part of our term we wanted to find, that minus 2 sine squared x cosine squared x. And all we have to do is figure out if that can be a 1, we're good. And if we go to our identity, it actually is a 1. The sine squared x plus cosine squared x, all of this goes away and leaves just a 1. So 1 minus 2 sine squared x, cosine squared x. Check that off, and we've got our answer. Okay, so this brings up a point that I wanted to kind of reiterate to you guys of really understanding your identities. So let me go back to the very, very top where I had you guys write identities. I want to show you something. So I'm sorry I kind of do this. Hopefully it's not too much of a headache for y'all to watch that, but look over here on this right column. I get to replace a sum of two terms with 1. If I add sine squared and cosine squared, I get 1. If I add tangent squared and 1, I get secant. If I add those two, I get cosecant, okay? Or the other way around, any other kind of manipulations of those. All of these over here on the left, though, the only way I can make a 1 is if I multiply two together, okay? So really, really pay attention to the differences there. Sine x, you can't just say sine of x plus cosecant of x equals 1. That's not true. This identity only says that sine x times cosecant x equals 1. Okay, so just keep that in mind whenever doing our problems. Okay, it looks like we have one to do, and then we can call this lesson done. I know it was a long one, but y'all remember this was a combination of two of these, so normally we would take 2 full days in the classroom to actually do this whole lesson, okay? All right, I've got secant to the 6th and tangent to the 6th. And over here on the right, I only have squares. So I want to take them from the 6th power down to the square power. And this one, again, this is one of those that pretty much I wouldn't expect you guys to see at all from the start. But after watching me, hopefully this kind of makes a little bit of sense. If I want to take secant to the 6th power and I want to write it as a squared power, what I can do is write it as, okay, secant squared t cubed minus tangent squared t cubed. Alright, so I'll take 2 seconds to see if you agree with this. All I did was rewrite a 6th power as a square cubed. A 6th power is a square cubed. So you just multiply these together. Okay, and by having it like this, my bases are both square terms and my exponents are cubes, so I have a difference of cubes and I can factor this. What's being cubed in the first is secant squared t. What's being cubed in the second parentheses is tangent squared t. And then using the rules of SOAP, remember the same sign over here on the left, and we'll have eventually opposite sign, and then always positive. Okay, what goes in the front of this second parentheses is this front thing squared, so we'll get it as secant to the 4th t. What goes here in the middle are these two guys right here in the front multiplied together, so secant squared t, tangent squared t. And then what goes in the back is that second one squared. So tangent to the 4th t. Alright, keeping on, keeping on. I'm going to look really closely at this first parentheses right here. I have an identity that tells me, in this identity, I know that tangent squared t plus 1 is secant squared t. So let's look at this. If I moved tangent squared over, it basically says 1 is equal to secant squared t minus tangent squared t. So I can replace all of secant squared t minus tangent squared t with 1. So this whole parentheses goes away and I just get a 1. Really, really, really nice, because now we can just almost, in a sense, just forget about it. We don't need it anymore. So really all I'm looking at is trying to get this right parentheses right here to equal that right side. Alright, so secant to the 4th, kind of what we did in this example right above this. Let's write that as a secant squared t times the secant squared t. That middle, we'll just leave it as secant squared t tangent squared t. And then the last is a tangent squared t times a tangent squared t. And like I told you guys before, let's choose to only replace, of the pairs where we've got multiples in there, let's only choose to replace like one of them. So I'll just leave the front one just there. And then secant squared is tangent squared t plus 1. Okay, we'll leave this in the middle as secant squared t times tangent squared t. And then I'll leave the first one and replace the second one, where tangent squared t is secant squared t minus 1. All of these are just manipulations of this very, very first one that I was looking at. Okay, we're running out of room, so let me get some erasing going on, and we'll continue right back. So let's take this last row right here and let's come all the way back up to, well, I'll just kind of continue up here at the top of my screen real quick. Alright, so let me distribute. I've got secant squared t times tangent squared t plus secant squared t. I've got the secant squared t times the tangent squared t. And then I have a plus a tangent squared t secant squared t minus a tangent squared t. Really, really long, but let's see if we got any terms that can maybe possibly go away. Or we can combine them together. I've got a secant squared t tangent squared t, secant squared tangent squared secant squared, which is the same thing. So you can just move those two terms around inside of each other. So I have a total of 3 of these, of secant squared t, tangent squared t. And what I also have is secant squared t minus tangent squared t. And if I write back up real quick, that identity that said tangent squared t plus 1 is secant squared t, you'll realize swapping these two around, or I'm sorry, moving the tangent one over like we had done before, moving that guy over, you would see that 1 is equal to secant squared t minus tangent squared t. And I've got a secant squared t and a minus tangent squared t, so those together become 1. So if I kind of finish this problem up, then I've got 3 secant squared t tangent squared t plus 1. Look into our answer, we've got it. Okay, so this was just writing them, choosing to write the secant to the 6th as a squared and a squared inside, so that when I did my factoring, we got all in terms of squares into the 4th powers. With the 4th powers, I just replaced them as 2 squareds and only used identities for one of the two. And then just finished them from there with algebra. And we have finished our last problem.